Okay, the next topic is, so now you don't want to drop, as I said, in most cases, dropping is not a good idea, unless, like all of or most of the values are missing, then of course you're probably better off dropping. But only if few of them are missing, then you want to impute, somehow come up with intelligent way of figuring out what could be the value that's missing, so we can insert that value. Okay. And that's done with fill-NA. And it's a fill-NA is your friend. There are many ways in which you can use fill-NA to fill missing values. Okay. And the most basic one is, of course, fill a particular value. Okay. Now I'm going to create a new data set, df equal to let's say np random seed 0. Let's use that, and then data frame random rand n, okay, normal random and novel 7 by 3. Okay. And then I want to insert some missing values in here. Say, so I'll do now to replace values, I need to use lock or ilock. Okay. So now, starting from the beginning, all the way up to 4, but not including 4, okay, in column index 1, I want to make all of those NA. Remember, NA is a nickname for np.nan. So NA is going to fill in missing values. And then let's say that we want ilock starting from the beginning up to 2, okay, comma, I have an additional comma there, equal to NA. Okay. So now I have a data set. Okay. Now I want to use fill NA, okay, and the most basic fill NA is to give a number. So df fill NA and I say 0. Okay. Then wherever there is a missing value, the missing value will be replaced by the value 0. Okay. Again, that's not a good idea, but it just gets us started with fill NA method. Okay. Now we can say that we can build a dictionary and then say, okay, column 0, we want this value, column, because in a data frame, different columns could be different things. So you don't want to use the same imputing value for all the columns. So you want different values for different columns. So for that, we have to define a dictionary. So let's say D1 is 1.5, right, to 0. So that means column label 1, missing value should be replaced by 0.5. Column label 2, okay, so instead of 1 and 2, so if you have names for the columns, then you can put the name there. And when you use name, you have to use quotation mark because it will be a non-numeric string. Okay, so and then we can say df fill NA and then give the dictionary. So now you see the column 1 values are replaced by 0.5, column 2 values are replaced by 0. And this is one of the most powerful ways of dealing with missing values, because you're going to have different filling values for different columns. And you set that up as a dictionary with column name is the key and the imputing value as the value. Set that up, give it to fill NA, that will do the rest of the job. Okay, and when fill NA will return back this, right? So you can capture it in a different data frame and use that. Or you can use, if you want this to be permanent, you have to use what? In place equal to true. In place equal to true will make it permanent. Okay. So modify existing object with the in place. So here are some more fill NA methods, okay, which are, I don't think these are very useful, but let's go ahead and look at them. So there is method. Okay, you can specify what method to use for fill in. So we have pad or front fill. Front fill is FILL, or so the last valid observation forward to the next valid. Okay, so propagate last valid observation forward to the next valid. Oh, I don't know. I'll just show you with an example what that is supposed to do. Okay, pad and fill, they are interchangeable. They're the same thing. And backfill and bfill, they are the same too. Okay, and okay, I'm going to set up another data set, okay, so that we can see the backfill and the front fill clearly as to what's going on. Okay, so I'm going to make it integer. So rand int, right, 1, 5, numbers from 1, 5, and then we want 7 by 3, and I want to then change 1, 0 to NA, and then 3, 0 to NA. So third row 3 and column 0. Okay, and then I want 5, 0 to be NA. Then I want 0, 1 to be NA. Okay, and then 3 to the end of 1, and then finally beginning till 3 in 2. Something wrong somewhere. here is where the problem is. I need one more. Okay. Okay. So now we have data set, okay, with missing values kind of spread over the place. All right. So now if you do df fill NA, and then you say method equal to f fill. Okay. So now what this is going to do is when it hits a missing value, you look at from the top, okay, it'll come down to the last valid value. The last valid value is then used as replacement for the missing value. So from here, as you come down, the last valid value is 1, that is used here. For this, the last valid value is 4, so 4 is used here. Okay? And 1 is used here. Okay? Now for this column, there is no valid values before this missing value, so it stays missing. Okay? Then the last valid value is 4 for all of these, so all of them are replaced with 4. Okay. Here, there are no valid values before it, so they stay, all of them stay as missing. Now let's look at, well, there is a slight variation to this. So we can limit how many we can use. So we can say limit equal to 2. So don't use it more than 2 times. So here you see that 4 is used 2 times and no more. So that is limit equal to 2. Okay. Now if you use backfill, backfill operates the other way around. Instead of using the last valid value, it uses the first valid value that comes after it. Okay. So here, so let's okay. So earlier, this was the first NaN was replaced by the last valid value before it, right? So it was replaced by one. Now backfill, it's replaced by the first valid value that comes after it. So it's replaced by 4. Here, the first NaN is replaced by 4. And these are replaced by 3. So bfill works the exact opposite way to ffill.